Starting from the top. Triangle proportionality theorem. What this is a line parallel to one side of a triangle separates the other two sides proportionally. That says proportionally. I feel like we could fill in almost every blank with proportional because that's the main idea here. And then if a line separates two sides of a triangle proportionally, then the line is parallel. What the heck does that mean? Let me show you over here in the picture. Okay, so here we have a triangle, and inside that triangle we have this line. Now this line is parallel to this line. If that line's parallel to this line, then there's proportionality here. So 18 is proportional to 6 in the same ratio that 24 is proportional to 8. So 18 divided by 6 is 3, 24 divided by 8 is 3. So those ratios are equivalent, and that means that this line is parallel to this one. And that's the gist of the lesson today. So we're going to go through and practice now. Okay, so the first example, it shows that these two lines are parallel. So that means this is proportional to this here. So we're going to do x over x plus 10 equals, and that means this is proportional to this in the same ratio. So 10 over 30. So as far as setting this up, you need to be consistent. So if I'm doing the small to big, then over here I also need to do small to big. There's different ways to do this, but as long as you're consistent, you'll get the correct answer. So for cross multiplication, 30 times x is 30x. Then set this up as 10 times x plus 10. And then we'll continue solving for x. And x equals 5. That's it. Okay, example 2 wants us to determine if AB is parallel to DE. So it wants to know if this line is parallel to DE. If it is parallel, then the ratios here will be equivalent. I can see you, Eliana. I got teacher eyes. And I told you yesterday not to eat in class. And I'm recording this. And your mask is down. Thanks, appreciate it. Okay. So I set these ratios up like this, and it's obvious that they are not equal. 15 over 6 is not equal to 15 over 7. So therefore, these are not parallel. So just like cross that out, not parallel. Yes?
So the lines that you draw, like little arrow things, does that mean parallel?
Yes. So for example, in this example, this line is parallel to this one. So for number 1, they're showing us that those are parallel, and if they're parallel, then we know there's proportionality here. 20 over x will equal 18 over 9. So I'm going to set that up. 20 over x, this is proportional to this, in the same ratio that this is proportional to 9. 18 over 9. And then you can use cross multiplication to solve. 20 times 9 is 180. Oh, there you go. X equals 10. So I will continue to solve it the exact same way each time so I don't confuse anybody. But you might also realize that 18 divided by 2 is 9, and 20 divided by 2 would give you this x here. So these are little shortcuts that could help you. For number 2, go ahead and set it up by yourself. So number 2, try it on your own. See if you can get the correct answer. Yes.
Are we allowed to use the shortcut?
Set it up though too. Yeah, because you won't always be able to use the shortcut with like decimals or expressions. Okay, what did you guys get? Did anybody get the answer? Oh, sorry. My bad. Okay. So as you solve it, as you finish it, if you got x equals 8, it means you did it correctly. Good job. For this, I'm not going to focus on the setup as much as the correct answer because there's different setups that would give you the correct answer. So one way I might set it up is x over 24 equals 10 over 30. And then when you use cross multiplication, you get 30x equals 240. Which equals x equals 8. Again, there's more setups that would work. You could also do 24 over 30 equals x over 10, and that would work as well. You'd get the same answer. But if you got x equals 8, you're good. Good job. You ready for the next one? Okay. The next one, number 3. Same idea. This time we have some expressions here. So this is proportional to this. So 6 over 18 equals, and this is proportional to this right here. X plus 2 over x plus 22. And then I'll use cross multiplication. Six times 22 is 132. And then x equals 8. Yes, Tyler. Did you get the right answer?
Yeah.
Then you're good. Yes, you could have done like 18 over x plus 22 and 6 over x plus 2, and you'd get the same answer. Then moving on to the next page when you're ready. Okay, another theorem, but this one's even easier than the first one. Triangle midsegment. The midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. So when we look at this picture, this right here, this segment joins the midpoints of this side and this side to create this midsegment. The midsegment is parallel to one side of the triangle. So this is parallel to this side right here. So then you have the proportionality here and here. And its length is half the length of the parallel side. So if this length, let's say it's 6 units, then the midsegment would be half of that, which would be 3 units. And the last statement, a triangle has 3 midsegments. I only focused on one here, but the other 2 are drawn. Okay, so how does that appear in problems? Here it is. For number 1, it shows that this length is 18. This length would be half of that, so 18 divided by 2 equals 9. So x equals 9. That's it. Number 2, same idea. This is half of the length of this. So to find x, 2 times 5x would equal 70. We get 10x equals 70. So x must equal 7. You could even plug it in to make sure it makes sense. 5 times 7 is 35, which is half of 70. Number 3, this is half the length of this here. So 2 times 4 would equal 5x minus 2, the length of the longer side. And then solve for x. Okay, so moving down to these two ideas, same thing, just in a different format. If 3 or more parallel lines intersect 2 transversals, then they cut the transversals proportionally. Where are those proportions? It shows the 3 parallel lines here in the transversals. The proportionality happens here. A to B equals C to D. And yes, A over C would also equal B over D, so you can do it that way as well. And then congruent parts of parallel lines. If 3 or more parallel lines form congruent segments on one transversal, then they cut every transversal into congruent segments. And I'll show you what that means in a second. The ratio of the parts is 1 to 1. So what does that mean? It means that if you're told that this segment here, segment U, is the same length as segment V, then segment W is the same length as segment V. Or sorry, segment X, I said the wrong thing. Okay, so now let's look at this in actual problems. And again, it's the same thing, just setting up proportions. So number 1, this is proportional to this segment here, so we're going to do 5 over 8 equals y over y plus 2. And then use cross multiplication. And it does come out to a decimal if you're already there. I get 3y equals 10, which 10 divided by 3 is 3.3 repeating, so y must equal 3.3 repeating, or 3 1/3. Okay, number 2, try to do number 2 by yourself. Take a second to set it all up and solve for x and make sure that you know what you're doing. Right, Rizzo? Rizzo conked out. If you get x equals 12, you got it right. So as you finish, if you get x equals 12, that means you did it correctly. Again, I'm not so focused on the setup because there's different ways to set it up. Is there anybody stuck or wondering what they did? Or no? Still working on it? Okay, I'm going to start solving it. 3 over x equals 4 over x plus 4 is how I'd set it up. Now you could have done 3 over 4 equals x over x plus 4. That's fine too. X times 4 is 4x. Then 3x plus 12. Then I get x equals 12. Okay, next one. The next one's different. At first, the first time I looked at it, I did set up a proportion, and then I realized that there's two variables here. There's both x and y, and you can't just solve a proportion or you can't solve anything with two variables like that. But then I looked at it closer. It's showing that this is the same length as this, so I can use that to find what x is. So I'm going to set these two expressions equal to solve for x. And then we get x equals 5. Then, once you know what x is, you could set up a proportion and solve for y that way, but there's actually an easier way. The theorem above stated that if these two are the same measure, then these must also be in a 1-to-1 ratio or equal to each other. So 3y has to equal 2y plus 2, and we can solve for y that way. And y equals 2. And that's it. So that's the end of the lesson. The rest of class you'll have to do your homework on this. If you have questions, of course, let me know. There are some fractions on the homework, so you might want to just change them into decimals before you start calculating. You can get your laptops and get started.